Support for Veterans Corner Radio is made possible by M&M Printing and the Observer News of Ruskin, Florida.
Hello and welcome to Veterans Corner Radio Podcast, information for and about veterans. For part one of this two-part podcast, Joe welcomes retired U.S. Air Force Colonel Adelbert Buz Carpenter. There are only 85 people on planet Earth who have achieved aviation greatness as an SR-71 Blackbird pilot. Retired United States Air Force Colonel Buz Carpenter is one of those pilots. In part one, we'll learn about Buz's life growing up, to his time as a cadet at our nation's Air Force Academy, and his transition from aircraft to ultimately the SR-71. Here now is Joe Mulberger with Veterans Corner Radio on Veterans Corner Radio Podcasts.
Welcome to Veterans Corner Radio, a show dedicated to providing information to all those who have served our country's military and to their families. Now, here is your host, combat veteran and educator, retired United States Air Force Lieutenant Colonel Joe Mulberger.
Ladies and gentlemen, welcome to today's show. I'm Joe Mulberger, and you're listening to Veterans Corner Radio. Well, we have the absolutely rare privilege today of introducing and welcoming to our show retired United States Air Force Colonel Adelbert Buz Carpenter, one of 85 people on the planet who was a pilot of the SR-71. Buz, welcome to the show, sir.
Joe, I'm delighted to be here.
Tell us about yourself. Where were you born? Where are you originally from? When was that?
I was born in Darby, Pennsylvania, which is a suburb of Philadelphia. Lived there for a few years. My dad was an aeronautical engineer, did test work during World War II, of testing our airplanes and also helping to test captured enemy airplanes. When the war was over, the government asked him to be an aeronautics instructor down at the Brazilian Air Force Academy. So as a young fella, I lived in Rio de Janeiro and Sao Paulo until I was probably about 6 years old. We moved to California. Well, my dad was an aeronautical engineer. My godfather was an aeronautical engineer helping design airplanes for the Navy, and I had another uncle. So I've had a long interest in aviation, particularly military aviation. Grew up basically in Oakland, California, and I graduated in 1961, and believe it or not, when I had talked to my high school counselor, I said, there's a new academy out there, the Air Force Academy, and that's where I want to go. And they looked at me and said, well, we know how to apply for West Point and Annapolis. But we have no idea how to apply for the Air Force Academy. So I had 2 years at what we called community college, because to go to the Air Force Academy, either you come in through being enlisted or you get an appointment from a senator or a congressman. Now, if your parents were in the military, there's another, but my dad was never in the military. So it took me 2 years to finally get through the bureaucracy and get an appointment. So I graduated in 1967 as part of the 9th class from the Air Force Academy, proceeded to pilot training. I had a pilot training. I wanted a fighter, but there were only back seats in the F-4, and I didn't want to do that. And then they wanted me to be an instructor, and the pilots who had taught me the most were ones that had operational experience. So I actually took a 141 and became an airlifter. It was the largest airlift airplane the Air Force had at that time as a co-pilot, but we flew worldwide. And because of the demands of Vietnam, we flew a lot. And so I was one of the few first lieutenants that upgraded to an aircraft commander in the 141, and it just taught me so much. From that, I was able to receive an assignment into the RF-4. I really didn't know what it did, but it's an F-4 not configured with weapons, configured with cameras. It led me to the combat tour in Vietnam, and there I met the colonel who had flown the first operational mission in the SR-71, and Colonel Jerry O'Malley, who later became 4-star General O'Malley. And he showed interest. He said, "You're the kind of pilot I would like to bring into the program. And when I leave Southeast Asia, I'm going to become the commander of the SR wing." And he said, "There's no promises. You're too young. You need a lot more. You need 2,000 flying hours." And at that point, I probably had 1,200 because he took the 141 time and cut it in half because he said, "You were a co-pilot. I'm part of that." And he said, "If you're interested, when I leave, I will tell my successor, if you meet the requirements, I would take a look at you." Well, I flew RF Force for 5 years, 3 years in Okinawa. And in 1975, I reported to Beale and started what would be a year-long training to become an SR-71 pilot and eventually an instructor pilot in the program until 1981. I then went to the Pentagon, and in the Pentagon, after a year, they moved me over to do classified projects. I think my SR background led to that. But one of the more interesting jobs I had in the Air Force, for a couple of years, I had all the Air Force very classified programs, the black programs, and helped with the manufacture of the F-117, the development of the B-2, the development of the F-22, and other projects even today I can't talk about. When I left the Pentagon, I went, trained into the F-4, became a F-4 squadron commander at Moody Air Force Base, and was promoted to colonel there, PCS to Europe, was in headquarters of USAFE for 2 years, and then became the support wing commander at Ramstein Air Base, the largest air base in Europe, and I had almost 4,500 people working for me, including 1,000 Germans. I was a commander there during the Desert Storm. To say it was a very busy time because we were a major support base, moving men and materiel through Europe down into the Middle East to support it. From there, I became the vice commander of 2nd Air Force, which had all the reconnaissance and surveillance missions in the U.S. Air Force. And eventually I would retire out of Beale Air Force Base in California, go into industry, and in industry work basically on finding better ways to collect information and to get information to our leaders so that they can make decisions, timely decisions to affect the different events that were taking place around the world.
Have you really retired? It sounds like you are so close to so many communities, especially the surveillance and reconnaissance, as well as the flying environment. Can you actually get away from it, or does it continuously call you back for reasons that only you would really know about?
I get called in now and then to give advisement. Matter of fact, right now, because of the uniqueness of the SR-71 engine, the J58 is a turbo bypass engine, and what that means is that once you got above Mach 2, around 1,400 miles an hour, there were 6 bypass tubes because you had more air at that 4th-stage compressor than the engine could absorb. So the air would be bypassed around the engine and directly into the afterburner area to provide additional oxygen, but more importantly, also additional cooling, because that back area was anywhere from 32 to 3,400 degrees. And unlike most engines, we ran those engines for an hour and a half at a time. We don't have engines today that can withstand that. They've been asking me to come back and talk to some of these design groups because we're looking at, for hypersonic, is there a way we can develop an engine that we can take off and fly like a normal airplane, and somewhere around Mach 3, convert it over to would be a tremendous bypass engine to be able to fly hypersonically. So in my work with the Smithsonian, I also work with about 28 other museums around the world that have any kind of a Blackbird, an SR-71, an A-12, to help them with the history, information for their docents to be able to give tours, and also information for their curators to use as reference. It keeps me busy, but Joe, it's a enterprise that I really enjoy, and I also use it as a way to reach out to classrooms across the country through Zoom or Teams and talk to young men and women and try to use my SR-71 experience particularly to inspire them to hopefully go into STEM or STEAM activities, become teachers, engineers, pilots, astronauts, whatever, but help them formulate visions, help them understand you have to understand, develop what are the requirements to go to realize your vision, and then you've got to pursue that vision or it's just not going to happen.
It's amazing. Now, tell us about this transition from heavy to fighter. Now you're in the SR-71. It's obviously, I mean, that's a miracle that people just are in awe about any time. It was a shocking moment when it was announced that it was going to be mothballed and taken out of service. But there you are on your third platform to fly. Tell us about what it's like. What's the significant differences as you're making the adjustment from those other two cockpits into the SR-71?
The SR-71 had a cockpit like a fighter's. It's not as primitive as the A-12, but it was like a fighter in the early '60s. And Kelly Johnson, who I had the privilege to have time with a number of times, just basically said, "Boys, you're gonna have to learn how to fly that cockpit. I've got bigger technical problems I've got to overcome." And that highlights why, even though you had 2,000 hours, when you came into the SR program and we're learning how to fly this magnificent airplane, it's gonna take us almost 10 months to get you up to a position where we can now send you overseas and start flying, particularly out of Okinawa, Japan, Kadena, your first operational missions, and then eventually into Europe for Mildenhall. And we did fly some operational missions out of Beale Air Force Base in California. We used to, every 45 days, fly over Cuba to keep track of the Russians and the Cubans. And some of the missions over Central America into the northern part of South America also originated out of Beale Air Force Base in California. The SR was a magnificent airplane to fly, but you really had to understand how was it engineered, because the average temperature of the airplane was almost 600 degrees. It grew 3 to 4 inches in length, an inch or two in width, and because of that, you couldn't use aluminum. The airplane's 93% titanium, and the titanium was procured by some CIA companies formed in Europe, and all the titanium was purchased from Russia. They never knew what its real purpose was, but they wanted dollars. So basically, we bought enough titanium to build 32 SR-71s, and you think back to it, the project started, it was because the need of President Eisenhower. They knew the U-2 was vulnerable. After it flew over Moscow on the 5th of July, 1956, that because the radar could see it at 70,000 feet, which was a real surprise, and there were missiles, SA-1s around Moscow that made, you could clearly tell the airplane was going to be vulnerable. So an advanced airplane was what was recommended. So Kelly started the design work in 1958. Well, think about it, just like the Mercury project and so many other things, it was designed with slide rules and tabletop calculators because computers weren't mature back then. So there was quite a process where you think these men and women, mostly men, that were engineers in the Skunk Works were able to overcome. And there were so many challenges that they had to reach out and be incredibly creative and come up with new processes. But the basic cockpit was a fighter cockpit from the early '60s.
Now, you didn't just throw a flight suit on and jump in, did you? There was a
No.
special flight suit, and tell us about that physiological preparations for getting into that cockpit.
You had to understand you went through the same kind of training our astronauts do. The first pressure or spacesuits I wore were Gemini suits. For a typical flight, you came in 2.5 hours early. You had to pass a physical before every flight. You then had a meal of steak and eggs, and about an hour 15 before takeoff, you would go down, and you had two technicians, absolutely very professional individuals, men and women. You'd put on cotton long johns because you're going to perspire a little bit. The suiting up process initially would probably take you 20, 30 minutes. I had over 230 flights. I would say that after a couple times, it was probably more like 10 minutes. The suit would be laying on the floor. You pulled it on like a coverall. The big seal was a zipper on your back. You would then put your helmet on. The suit weighed about 40 pounds. The helmet was 2 or 3 pounds. You then put on the gloves. They would inflate the whole thing and do all kinds of series of tests to make sure that everything, your communication, your oxygen system, your ability to hold a seal, just like in your car on a rainy day, you had defog because the moisture in your breath would cause the inside of the helmet to fog over in very short time periods. So you had what face heat would be on, and you could feel it with your eyes. About 45 minutes before your your takeoff, they would take you out, install you. I mean, it's a very small cockpit. So these men and women would be laying on their stomachs, and you put your arms up on the rails, and they would literally reach in and make all the critical connections. The engine start was 30 minutes prior to takeoff. You went through a whole series of, it wasn't the kind of airplane you jumped in, kick the tires, light the fires, and go. There were a lot of tests you had to go through to make sure everything was correct, and then carefully taxi out to the runway. And we typically took off with half a fuel load because we had lost 3 SR-71s during the test program trying heavyweight takeoffs. The tires were very sensitive, so we basically took off typically with a half a fuel load, 40,000 pounds of fuel, and we would then head up to a tanker and then top off and go. Now, we could take off with a full load of fuel, but that was an exception. One of the things I liked was take off with 50,000 pounds of fuel from Beale Air Force Base with a student and go right immediately to altitude and to Mach 3, and about 25 minutes later start down and refuel over El Paso because it gave them more time to going through the transitions. People ask me, what's your greatest sense of speed? Well, at altitude, you don't have a sense of speed because you're in a spacesuit. All the sound is behind you. There's nothing near you. You need clouds and other stuff. Well, off the coast of Florida with thunderstorms, you might see something whizzing by a little bit. But your greatest sense of speed is on takeoff. Can you imagine you're cleared for takeoff? You light the 2 powerful afterburners. In 20 seconds, you're going to go 4,500 feet, and you're going to lift off doing 240 miles an hour. That's 210 knots indicated. You're going to pass through 20,000 feet less than 2 minutes from the time that you start your takeoff roll. You're actually pushed against the seat somewhat. The SR is not a high G airplane. The most Gs you can pull if the airplane has not accelerated is 3.3 Gs. At altitude, once the airplane is heated up and expanded, all you can pull is 1.7 G. So that's a 45-degree bank turn. And that's why it takes you, if you're at Mach 3, going to take you about 160 miles to turn around. That's your cross-section. So you can see, like, we could turn around Texas and California, but if you were up in New England, you used up a number of states to get turned around.
So the SR-71, it takes on a special fuel type as well, right?
JP7, because normal jet fuel will ignite at minus 40, it fumes at minus 40 degrees. JP7, because the airplane was so hot, you have to get it above 186 degrees. So to start the engines and to light the afterburner, there's actually a chemical injected into the engine that explodes at 3,000 degrees, and that really nicely lights the fuel. And so you have a stable fuel that you're burning. Every time you refuel, full tanks is about 12,400 gallons. You're going to burn that in 2 hours, but you're going to go over 3,000 miles. So like my longest mission was 10 hours and 20 minutes. That's from Beale Air Force Base to the north coast of Russia and back. So I went over 15,000 miles, probably burned over 75,000 gallons of fuel, and refueled 5 times.
So the refueling part, you got to put those tankers into orbits. You have to have tankers that are dedicated with that specific fuel type to make that happen. And you keep talking about altitude. The altitude for the C-141 may have been 1 altitude. The altitude for the F-4 may have been 1 altitude. What's the altitude for the SR-71 when we're talking about being at altitude?
Normally at altitude, if we're going to be flying at Mach 3 to 3.2, which is our nominal top speed, you're going to be between 80 and 85,000 feet. Typically, you burn a 30 of your fuel to climb and accelerate up to 80,000 feet. So as you burn off fuel, you let the airplane continue to climb. So you may level off at 80,000 feet. And as the fuel burns off, you may end up at 83 or 84,000 feet. If you're in really cold air, you actually may end up above 85,000 feet. It's really depending on the outside temperature. It's not always minus 80 degrees Fahrenheit, which is minus 55 degrees centigrade. I've seen it as warm as minus 40 degrees centigrade, which means you're going to be flying at a lower altitude because the air's thinner. Off the north coast of Russia and other places, you could get into air that was minus 90 degrees centigrade. And now the airplane really wants to climb because it's got so much more lift, and the engines are happy because the air coming into the engine is denser. And one of the amazing things of the engineering, that you carry the shock internally as it comes in. At sea level, 14.7 pounds per square inch is where our atmosphere is. At altitude, where we're flying on the edge of space, it's 0.4 pounds per square inch. But the way the inlets were designed, it compresses. So you have minus 80-degree air, 0.4 pounds per square inch. It comes in, it's mechanically compressed in the front, and then goes, when it meets that first stage compressor, it is now somewhere between 15 and 17 psi. The engine thinks it's below sea level. The temperature of the air entering the SR-71 engine is above 800 degrees because as you go through the compression cycle, as the air is crunched together, it heats up. So when they tested these engines, they used to have to run a J75 engine in front of the J58 engine to try to simulate the air and the temperature that engine was going to absorb when it was actually during cruise.
So those tanker orbits, they are not at that altitude. What is altitude for them?
The tankers were typically at 25,000 feet. That was kind of their sweet altitude. And they would go as fast as they could go. And sometimes if because of the air temperature, when we got above 70,000 pounds of fuel on board, we'd have to light the left afterburner because we just didn't have enough energy. And you just warn the tanker, particularly at night, because all of a sudden this big flame would be coming out one side and you didn't want the boom operator to panic, to think that there was something wrong with the airplane. This was just normal operation. We refueled in my 230 some flights. I can only remember one or two that I possibly didn't refuel, and they were probably maintenance flights that I was bringing an airplane back that was not capable of flying supersonically.
That's significant. So how long, I mean, you got to plan out every one of these times to come in to refuel. Now, who is bringing you in from altitude to tanker altitude for refuel? And how long, distance-wise, does that take? And time-wise, does that turn into just to get there?
That's one of the primary jobs of the reconnaissance systems officer, the navigator in the back. And he had the equipment back there, like your TACAN. You know, a normal navigation TACAN will show you the direction and distance to a electronic beacon. Well, we had a secure communication system that we could see where the tanker was over 300 miles away. So about 210 miles back, the navigator would say, okay, let's start down. So you'd come out of afterburner and you had a very controlled profile. You had to fly down to make sure your engines didn't compressor stall. So it took you about 10 minutes and you're going to fly over 200 miles, and the tanker would plan. They would see where you were. And the whole idea was they would make their final turn just about the time that you were coming level. And if everything worked out, you'd end up about 1 mile behind the tanker, about 500 feet below him at 25,000 feet.
Well, here on Veterans Corner Radio, we say our veterans are worth their value in gold. And, sir, if you would indulge me, we're going to close this section or this session of Veterans Corner Radio, and we're going to call this Buz Carpenter's interview number 1, and we're going to make this a 2-part show. So we thank you very much for your time today, and we're going to continue because this is just too interesting not to continue the march with. So thank you for your time, sir. We will be wrapping this episode up, but we'll be back in touch. Thank you, sir, for your time.
You've been listening to Veterans Corner Radio with your host, retired United States Air Force Lieutenant Colonel Joe Muhlberger. The views expressed on this program are those of Joe and his guests and our opinions based on the best available information. In matters of law or governmental regulation, it will always be best to check with the appropriate agency. Thanks for listening, and we hope you'll join us for the next program on Veterans Corner Radio.
Here's a quick final thought. If you're enjoying these podcasts, why not take a minute to subscribe or mark Veterans Corner Radio as a favorite? It's easy, and you'll be set to be among the first to find out when new podcasts are published. And thanks again for listening to Veterans Corner Radio.